Welcome to solverfy.
So in this problem, we have to find out or rank this following samples in order of increasing number of atoms. So the first one is 42 gram of sodium bicarbonate NaHCO3, and then we have 1.5 mole of carbon dioxide, and we have 6 times 10 to the power 24 atoms of neon, and we have to arrange them in order of increasing number of atoms. So to do that, first, you have to find out how many moles of sodium bicarbonate we have here, and from there, we'll have to find out how many atoms is present in that number of moles of sodium bicarbonate. And we are given here the number of moles of CO2, so we just have to find out how many atoms we have in this number of moles of CO2. And in this case, we are just given the number of atoms of neon, so we don't have to do any kind of calculation here. So to find out the number of moles of sodium bicarbonate for 42 gram, we have to find out the molar mass of sodium bicarbonate, and we can just do that easily by adding up the atomic weights of each atom present here. And since sodium's um, atomic weight or molar mass is 23, then for hydrogen we roughly uh, consider 1 for hydrogen. For carbon we consider 12. So these are all the molar masses of each atom present here, and we have 3 oxygen, and for oxygen it is 16. So for 3 oxygens it will be 3 times 16 or 48, and this will give us a value of 84 gram. That means 84 gram sodium bicarbonate is 1 mole, and here we have 42 gram. That means 42 is half of 84. That's why we have half mole of sodium bicarbonate present here. So we have half mole of sodium bicarbonate, we have 1.5 mole of CO2, and we have 6 times 10 to the power 24 neon atoms. Now we have to find out how many atoms we have in this 0.5 mole sodium bicarbonate. So as we know that in 1 mole of any uh, compound or molecule, we have 6 times 6.02 times 10 to the power 23 molecules in 1 mole of any molecule. And also, so that means 0.5 mole NaCO3 contains half of this, because 1 mole contains this much. That means half mole contains half of this, which is 3.01 times 10 to the power 23 NaCO3. So this is the number of molecules we have in half mole of sodium bicarbonate. Now in a sodium bicarbonate molecule, how many atoms we have? We have 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygen. That means in total we have 6 atoms in 1 molecule of sodium bicarbonate. That means in 3.01 times 10 to the power 23 molecules of sodium bicarbonate, we have this multiplied by 6, or 6 times 3 is 18.03 times 10 to the power 23 atoms. I'm repeating it one more time. So in 1 molecule of sodium bicarbonate, we have 6 atoms one sodium, one hydrogen, one carbon, and three oxygen. That means since half mole of sodium bicarbonate contains this much molecule of sodium bicarbonate, that means in this much molecule of sodium bicarbonate we have this times 6 or 18.03 times 23 atoms in half mole of sodium bicarbonate. Now we have to find out how many atoms we have in 1.5 mole CO2. So 1.5 mole CO2 will contain um, 6.02 times 10 to the power 23. So that is the number of molecules for 1 mole. That means for 1.5 or 1.5 mole, we have to multiply it by 1.5, and it will give us 9.03 times 10 to the power 23 molecules of CO2. Now, in one molecule of CO2, we have one carbon and two oxygen, that means three atoms. And that's why in this number of molecules of CO2, we have multiplied by 3, 27.09 times 10 to the power 23 atoms. So again, in 1.5 mole of CO2, we have 9.03 times 10 to the power 23 molecules of CO2, and in one molecule of CO2 we have three atoms. That means in this number of molecule of CO2 we have this number of atoms. So now if we and in one other sample we have 6 times 10 to the power 24 neon atom. So from here we can easily say that none of the sodium bicarbonate or CO2 is anyway closer to neon atoms, since they are 6 times 10 to the power 24. That means um, so this is the maximum number of atoms present in one sample, 6 times 10 to the power 24. And then we have the lowest, we have the second highest in 1.5 mole of CO2, which is to, 27.09 times 10 to the power 23. And then we have the lowest number of atoms in half mole of sodium bicarbonate, which is 18.03 times 10 to the power 23. So if we just arrange them in rank, neon in the increasing order, it will be NaHCO3 is the lowest, then CO2 is second highest, and neon is the sample with the highest number of atoms present in it.